more exploratory than the previous one. Because this is an idea that we have been playing with the idea, and just recently we have got results. So there are a few things that I won't be able to address probably if you have too many questions. But feel free to make questions, because this is will help us to develop further this kind of application. So the main topic that we're talking about here is the variability between students regarding the endorsement of gender equality. So we're coming from the citizenship framework, which we're saying that the students not only should go, let's say, to vote and have some knowledge regarding how institutions works in the country, but they also need to be active to be able to confront discrimination when it's happening. And under this overarching idea, then that means there are a few things that are not necessarily knowledge and not necessarily participation of the students, probably would be something else, that we think there are at the core of citizenship development as well. One of them is, for sure, the endorsement of gender equality across students. So the main point here is that why we think these are really critical for the process of socialization of students within schools is that there is evidence there when this kind of attitudes varies between students is not necessarily the most positive school climate for girls. They can internalize this kind of stereotypes. This would affect their school life throughout, even at later stages in their life, because they're going to externalize certain ways of how to be and what kind of jobs they need to take and so on. And there are like even more difficult outcomes that you wouldn't like to have. Like what kind of norms students that are males are addressing and how they would treat their peers when they are either at their school and later in life at their work and even with their partners. So there is I would say like a larger agreement between different lines of research that this is a key component that should be promoted and is convenient for improving the living conditions of all. So now I'm going to show you how this is measured, what kind of items are used within ICCS. And what we have here is a collection of 7 items. Only 6 of them are used to generate scores for gender equality. So we have assertions such as men and women should have equal opportunities to take part in the government. And that kind of item, it's addressed in the literature as a gender equality measure directly. Whereas the reverse scores that I'm highlighting there, like when men and women should get equal pay when they are doing the same jobs, or men are better qualified to be political leaders than women. Sometimes in the literature you can find them as examples of hostile sexism or attitudes toward women capabilities. This idea of making a distinction between what items are referring to equality and what items are referring to women's capability are coming from the authors that are there. So we have Carlos and Daniel that proposed this distinction. So what we know is that we have 3 scores that the higher the students give you agreement, you have a higher propensity of endorsing equality among men and women. And the other ones are expressed as sexist items. And I would say usually that would be the practice to have 3 and 3. They are balanced, so you have reverse items, you have direct items, you just reverse them, and then you would have like a continuous score. The way that the scores are retrieved with these kind of items is using a partial credit model that gives you a score that the higher you go, that means that you're more likely to respond to categories 2, 3, and 4. So if you're in this extreme, that means that you're more likely to respond to the category 4 for all items. And with this kind of response model, we also can see like which are the more popular items and which are like the more difficult items, the less popular across all the students. And for the work that we did for UNESCO, the idea to try to find a way to characterize gender equality across the students was then to use this threshold as like as a point of reference. Because given that we know the information regarding how the response model works, then we could say that the most likely scenario, all the students that are above this score, they're more likely to say, I agree with all the items that they should agree, and they disagree with all the items that they should disagree, to express a higher endorsement of gender equality. If you look closely to how the histogram looks like, we have a high ceiling effect. So it's a bunch of kids, girls and boys, they're at the top of the score. If we take that threshold and we retrieve the percentages of students that are at that point of the scale, this is more or less how they look like between different countries. I'm just going to pick like a few just to give you like a hint. Like we'd say Sweden is 74% of the students are at that point of the scale. So there is a large proportion of students that endorse the highest gender equality that you can retrieve with these items. Italy is about 60%, is 58. Chile is like 47, and so on. The main point is that we have variability. What we wanted to do was to make a different question. So, because once you have a continuous measure, you can use, let's say, a mixed model, a regression model, and you would say, okay, I have the intercept of the population, and I can move up or down regarding whatever school factor that we're using, or student size. What we were wondering is, what can we do if you want to make inference regarding that specific point on the score? So we want to have inferences regarding the students that are at the top of the gender equality endorsement. Because these would be the students that are satisfying or fulfilling the what was proposed in the SDG. What we thought about was to report to the idea of using a zero inflated model. Zero inflation is when you have a measure of counts. So let's say that you have a zero, and then you have a count that tends to go down. And they tend to have like a really, really long tail. A common example of zero inflation models is when people is asked how many cigarettes they smoke. So the people that do not smoke, they have a zero. And the people that do smoke, they would have a higher number, and then it decays. Because the people that really, really smoke is really few. And the other thing that you can do with those kind of distribution is that you would have a two-part inference. So you make inference regarding the ones that are at the zero, so the ones that don't smoke, and the ones that are at the higher levels. So the ones that, you know the distribution of the ones between ones and the rest of the remainder of the distribution, and you can also make inference to that. What is difficult here is that we don't have a count in such a way. There is no zero. IRT scores do not generate a zero in the same way that sum of events generate a zero. A zero event in a sum of events, for example, would mean that there is the zero attribute. So there is a school practice, for example, that doesn't happen. But we think that even if it doesn't have it, it might be possible to retrieve it some way. The main issue that we're trying to dabble with in this case is it might be the case that we can rethink how measures are done, so we can retrieve specific information that we might be looking for. And what we want to do is to move further to other measurement alternatives that are out there. One of them, the extreme one, would be to have an unordered latent class. So instead of looking for a continuous measure, we just model the response patterns. And then we will say this is the response pattern of interest. Like an in-between would be to have those scores and then to have different latent classes, but they are ordered. And then we will know that certain latent class that is at the top is the one that we're looking for. We're going to do a shortcut, and I'm going to explain how. So the idea, if we're going to move to a different measurement model, we could go to all of these other alternatives. And it would be possible to generate a sensible and interpretable response model to achieve that goal. Remember that we are interested in the students that endorse gender equality at the most, because we want to know what specific school factors are doing that job. So there is one property in IRT, particular for partial grade models. There are other IRT models that have that same property, that is called monotonicity. You can take the sum score, you can take the IRT score, and it's going to give you like a heap curve shape. It's because both scores can give you the same order of the students. And at the same time, because we're keeping the scores that were generated with the original response model, we can also make interpretations that can go back to the response model itself. So then that would mean when we retrieve conditional means, we can say, and this is the expected responses out of those students. So we can describe what it means to be one standard deviation away from the main center in the distribution that we have. So now, this is the representation with the score that we're going to use, which is just the reverse of the sum of the responses. So now the 0 is the peak of the IRT scores. And then the rest of them are going to be a count of a rank order of sexism endorsement. So they're going to look like this. So for the first part, which we are interested in, is the students that are above the threshold of the STG. In this way, and in this case, it's going to be a more strict one. Because the 0 that we're generating is that a little bit further away in the gender equality endorsement distribution. And for the remainder of the distribution, we're going to have different factors that are, if they promote sexism across students, are going to be positive. And if these are protective factors for sexism, they are going to be negative. So we're going to do this with Italy. It's not that we have something against Italy. It's just we pick Italy for illustration purposes for the conference. So we're going to use ICCS 2016, the Italian representative sample, as outcome, this score that I was telling you. So it's the reverse of the sum score of all the responses from the students. As covariates, we're only going to use like a few. It's just the student sex, mother's education, and open classroom discussion. And at the end, we're going to use a zero-inflated model, in particular, a negative binomial. Because the dispersion of the remainder of the distribution is really, really tailed. And we also can do it with using sampling design, so we can make inference to the population of the students in Italy. And what I can tell you with this brief model, because it's just an illustration, is that we know now that girls are more likely to be in the top of the endorsement distribution, the threshold that we have defined. So there are more girls in that group. For all students, whether are their mother have tertiary education, they're also more likely to be in that group. If they're attending a school in which they have higher levels of classroom discussion when there are political issues in the discussion, they're also more likely to be at the group. And following the question from Herman in the back, we see something regarding the deviation of the students. So apparently the students that are more willing to say that the classroom discussion is occurring, they're also in that group. So it might be the case that the students that deviate from their peers when they're rating the open classroom discussion, they might have some sort of substantive meaning. But as I said, it's not part of the questions of this presentation either. And I think we need to address that, but we still don't know how to do it systematically. The left side of the table is giving us, like, here we're conditioning the counts, and these are not counts that we can make an interpretation as counts. These are just rank orders. So what we know there is that for the remainder, so these are the students that are not in the top, girls are less likely to be more sexist than their peers. The students that have mothers with tertiary education as well, they are less sexist than their peers. And the same pattern we observe with open classroom discussion. So I already described you the results. So these are like the things that I would say that we are discussing within the group that are dabbling around with this solution. Again, this is not something that we just like came out of the blue. There are precedents of this application. It's on the back. They did that for measures of Boolean events. The only difference that instead of, we're not using Boolean events, we're still using a polytomous order scale, but we're reversing the sum score. And we believe that we can make the same interpretation for the model. The model itself is just like a representation of the information that we have. And we are using the model as such. One of the limitations that this approach has is that it cannot handle missing values. So this monotonicity looks like really ideal only when you have complete response patterns. If you have missings in between, then the sum score means something else, because you're not summing up all the items that should be there. One way to address that issue is to make imputations using the response model, and then you can also represent the measurement uncertainty for that sum score. We think that this idea might be helpful not only for gender equality measures. There are several different kinds of measures in this kind of field that present this distribution, ceiling or floor effects. And when you have really high ceiling or high floor effects and you're working with program evaluations, it might be the case that you're getting underestimates of the program, because you are not addressing these accumulation of cases at the top or at the bottom. And however, we need to be sure that this is like a helpful tool for that purpose. We need to make more simulation steps, so we can then more clearly deliver this kind of tool for those kind of problems.
Thank you, Diego.